Okay, in this example, we have two masses which are connected. One is on an incline and the other one is hanging. So what happens is we will have an acceleration of the masses. It could be up the incline or it could be down the incline. So what we first need to do is draw the free body diagrams for the respective masses. Okay, let's start off with the 5.7 kg on the incline. So what I have is I have a weight, so it's 5.7 g gravity. I have tension, which is the rope that's pulling upwards, and I have a normal force because I'm sitting on the incline, so I have a normal force here. Okay, for this system on the incline, I would likely use a coordinate system that follows along the incline, so I'll use this as my coordinate system. And if I have this coordinate system, that means I actually need to split my angled component, which is the weight, into its y and x components. So it means I have to split it to this and this one. Okay, so we know that the angle between this area is 35 degrees. So therefore this will be 5.7 g cos 35 degrees, while this will be 5.7 g sine 35 degrees. Okay, g is actually representing the gravitational acceleration. So for the hanging mass, we have T that's holding him back, and then we also have its weight, so it's 3.2 g. Okay, so for this first instance, let's assume that the acceleration is in this direction. Therefore, for the 5.7 kg mass, it will actually be going upwards along the incline. Okay, so what we then now need to do is put together their force equations in the relevant coordinate system. Let's start off with the 5.7 kg mass. So for 5.7 kg, so in the y direction, I have n plus negative 5.7 cos, sorry, 5.7 g cos 35 degrees equals to 0. And in the x direction, I have t plus negative 5.7 g sine 35 degrees equals to 5.7a. Okay, now for the 3.2 kg mass, I only have most of the forces in one direction. So in vertical, I have 3.2 g plus negative t equals to 3.2a. Okay, so I have three equations that I could possibly use. Okay, from what I noticed, we'll just need to solve for a. So it looks like equation 3 and equation 2 would be sufficient. So from equation 3, I actually get t equals to 3.2 g minus 3.2 a. Okay, now what we do is we substitute 4 into 2, sub 4 into 2, and what we get is 3.2 g minus 3.2 a minus 5.7 g sine 35 equals to 5.7a. So therefore 8.9a equals to 3.2 g minus 5.7 g sine 35 degrees. Okay, and that would give me A equals to 9.81, which is our g, times 3.2 minus 5.7 sine 35 degrees over 8.9. And therefore, what we get as the answer is negative 0.076 meters per second. So by getting a negative value for the acceleration, so what it means that actually the acceleration was going in the opposite direction. So instead of the 5.7 kg actually moving up the incline, it's actually moving the opposite direction. Okay, so this is the answer.